Hello friends, today we study about a transistor. Transistor is very important device for different electronic circuit. Even though transistor is used in power converting devices, there are so many applications just like amplifier, transistor used as a switch in telecommunication, in power supply devices, etc. So today we know about a construction of transistor, its characteristics, and its different topics. But first of all, to know about a transistor, before we know about what is transistor, we should know what is the need of electronic devices. We study so many electronic chapters, some topics, and also there are lots of subject in just like electronic, power electronics, microprocessor, etc. But what is the basic need? What is the basic need to know what why we study the electronic devices and what is the use of electronic devices? So here some information to know why we need the electronics. Look, electronics used in telecommunication, information processing, signal processing, power converting devices, and etc. There are lots of electronic devices. Even though there are so many electronic devices surrounding us, just like TV, cell phone, our mobile charger, even though today the solar technology is going very vast. So in solar technology, the inverter, charge controller, these are the one kind of the electronic devices. But basically that electronic device is act as a switch that make the digital information processing possible. Although using electronic devices, we are make a device in compact size. At the past time, where there is no any semiconductor technology, semiconductor devices are not used, so consequences the devices become very big. Even though the fan controlling regulator is also become a very big. Even though it 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 was generated so many heat, so the chances of damage that regulator is more and more. But today, using semiconductor devices, the fan regulator is become very small, very compact, easy to install, and easy to control a fan with good efficiency, minimum heat consumption, and good controlling output. Look at some example. Here are some example that how the electronic device is influenced in our electronic side. Look at this. At the previous time, where there is no any there were no any kind of semiconductor devices, then the resistors is look just like this. It is the wire wound rheostat, and it is the controlling probes. You just it will move in axial position, then it will controlling the current and voltage and whatever the parameters we want to control, but it generate the more heat. Sometimes it is the more chance to damage these devices, but nowadays it will become very compact. It has a more rating compared to this rheostat and easy to control. As well as you can see that this is the old fan regulator. This is this kind of resistors which is tapped to some different values, and this is the probe. Then you can move it, then it will change the arms of resistance, then it will control the fan speed. But nowadays we are using this kind of regulator. It is very easy to install, very easy, uh, very easy to control. Also, it gives you the more fan controlling output, etc. So this is the influence of electronic device in our life. So it is very important to know electronic devices, and we can make more and more compact devices using electronic circuits. But before making the circuit, we should know what are the electronic devices, what is its operation, where we can use it, and how it become a more important part to the total system. So there are three kind of materials. There are three type of material used in our electrical side. There are the three type of material. The materials are conductor, semiconductor, and insulator. Look, every material has electrons, and this electron is help to flow the current from one side to another side. But every materials are not help to flow the current in our circuit. The only the material which is considered in conductor, that material is help to flow the current. But in semiconductor, it has some forbidden energy gap. Look, in conductor side, there is no any kind of energy gap. So the electrons is placed on the valence band. Look, valence band means there is no any kind of activity by electrons, or in another way, we cannot excite the electron, or we cannot give any kind of energy that can electrons transfer the energy from one side to another side. So in conductor there is no any energy band gap. So when you some excitation, then it will be goes from valence band to conduction band. And when the electron goes from the valence band to conduction band, it is easy to transfer the energy from one point to another point, and it is easy to transfer the or flow the current in our circuit very easily. But in semiconductor devices, it has some energy gap. Energy gap means we require more energy compared to conductor to flow the electrons from valence band to conduction band. And when the electron goes from valence band to conduction band, it can easily flow the current on our devices. So this is the energy gap. This energy gap is 1 electrovolt unit. So when you give some energy more than 1 electrovolt, then electron easily goes from one point to from valence band to conduction band. But in insulator, the gap is more. The gap is more. So the required energy to flow the electrons from valence band to conduction band is not easy. So that is why insulator, it's not help to flow the electron from one side to another side. If we want to make an insulator as a conductor, then we require a more energy, more voltage. So here we discuss about the semiconductor devices, and using semiconductor material we can make a different electronic devices like diode, transistor, thyristor, MOSFET, etc., which is very useful in different electronic devices. We can also understand in another way of three different materials like this. You can see that conductor has no any kind of energy gap, valence band and conduction band. The semiconductor material has a valence band, conduction band, but between these two, the 1 electrovolt energy gap is that, which is approximately, not exactly, but it is in approximately. Even though insulator has a more energy gap, which is 5 electrovolt. So this is the briefly explanation about conductor, semiconductor and insulator, and how it is important for our electronic circuit. Now let's we know about different type of semiconductors. Look, there are the two type of semiconductors. First is extrinsic and another is intrinsic. Now what is extrinsic and intrinsic? Extrinsic material, it is the material that we mix some impurities, and intrinsic material, we are not mix any kind of impurities. So extrinsic, it is very useful to make a semiconductor device. Most probably every semiconductor devices are based on extrinsic, because we mix up so many impurities, not so many, but required to make any kind of electronic devices. So in extrinsic material, there are two type of material, P type material and N type. Now what is P type, N type material? We will discuss in after some slides. But intrinsic material has only one, because there is no any kind of impurities we are mixed up it. So there are the two type of semiconductor devices, extrinsic and intrinsic. Extrinsic has a more two subtypes, P type material and N type materials. Just remember it. It is very useful for our any interview side. Here some difference of extrinsic material and intrinsic material. So let's discuss step by step that intrinsic semiconductor means the semiconductor which is extremely pure, no any kind of doping. We are not doped any kind of impurities. It is pure. Either you are use silicon, then only silicon is there. Either use or use a germanium, then only germanium, or any kind of semiconductor device, but only a one semiconductor device. We are not mixed, or we are not doping any kind of impurities. But extrinsic material, the amount of impurities are doped in pure semiconductor. Amount of impurity are doped in pure semiconductors. Look, semiconductor materials is silicon, germanium, etc. But on silicon material, some impurities or some materials are adopted on that semiconductor, and it will become an extrinsic semiconductor. But in intrinsic, there is no any kind of impurities, just only silicon or silicon. So the small amount of impurities are adopted in pure semiconductor devices. This is the basic discrimination between extrinsic material and intrinsic material. Look, intrinsic semiconductor, number of free electrons in conduction band is almost equal to the number of holes in the valence band. Number of holes in valence band means quantity of electrons and holes are both are equal, because definitely there is only one material used, one semiconductor is used, so obviously it is equal. But in extrinsic material, if you use N type material, the number of electron is more compared to hole, and if you use P type material, the number of hole is more compared to electron, because we doped impurities. So that's why the ratio of electrons and holes both are unequal. Another difference is that electrical conductivity is the function of temperature alone. When the temperature is increases, the intrinsic semiconductor behavior is become a change. Definitely it will become a change, because temperature is also the one parameter to affect or influence our electronic devices. But extrinsic material, the electrical conductivity, the function of temperature as well as the concentration of impurities, donor, either acceptor, atoms adopt it. Intrinsic material, there is only temperature is affected, but the extrinsic material, temperature as well as the whatever the impurities you are adopted, it will also affect, because every materials are influenced on temperature. So the behavior of every materials are not same. So that is why in extrinsic material, temperature as well as the whatever the material you are adopted is a function of electrical conductivity based on temperature. Another, that the energy level lies at the center of the forbidden gap. But extrinsic material, n-type energy level lies at the bottom of a conduction band, whereas the p-type, the level is lies of the top of the conduction level. Intrinsic material is have a bad electrical characteristics, but the extrinsic material has a good electrical characteristics. So on the basis of that difference, we conclude that the extrinsic material is extrinsic semiconductor is a good semiconductor to make our electronic devices. So above up to till that you will be clear that what is the need of electronic devices, what are the three basic materials and which material we are used in semiconductor, what are the type of semiconductor, and what is the difference between intrinsic as well as extrinsic material. This is not a total discrimination. There are so many discrimination, but some common discrimination I consider in the difference between extrinsic material and intrinsic material. Now here we discuss about the P and N type material. P type material and N type material. In previous slide we discussed that what is extrinsic and what is intrinsic. Here we discuss about the extrinsic material. Some impurities is adopted on the pure semiconductor, so that is why the quantity of electrons and holes are not equal. So here you look that this is the P type material. P type material most probably considered as an acceptor ions. Acceptor ions means it will accept the ions because the number of hole is more compared to number of electrons. So the majority carrier is hole, minority is electron. But in N type semiconductor, the number of hole is minority carrier, but the majority carrier is electron. That is why it called as a donor ion. So the P type material is an acceptor ion, N type material is a donor ion, because P type material as majority carrier is hole and N type material as a majority carrier is electrons. And why the hole and electrons quantities are different, that you know that. We can also understand the P type material and N type material is just like that. You can see that number of holes and the negative charge. This is the free electrons, number of charge is more. You can see this. So it is easy to understand what is the P type material and N type material. Now here we discuss about how the P type material and N type material, when we give the electrical supply, what is the behavior of P type material and N type material. Here you can see that Here you can see that this is the p-type material. It has a small hole. It has a majority carrier is hole and minority carrier is electron. So when you give the potential difference, or when you attach the battery to the p-type material, you can see that the hole goes from the negative polarity side and electron is flow from the negatively side. So the flow of current is direction of current. This is the free electrons. So the majority carrier charge is hole. So the direction of flow of this is the direction of flow of current. You can see if I make a full screen. You can see that this is the direction of current. When you attach the battery, the hole is goes from the negatively polar or negative polarity, and electron is goes from the positive polarity. So the flow of current is so much small because the number of electron is very small. So that's why the flow of current is not so much, but it will flow the current. Now another is a n-type material. Look at this, the n-type material. N-type material has a number of electron is more compared to the hole. So when you attach the battery, the flow of electron is on the positive charge, positive polarity, and hole is goes from the negative polarity. Here, look, hole is not a flow of hole is not flow. Every some books are that the hole is flow from the and electron is flow from that side, but most probably when the electron takes place its position and goes to another position, then there will be a space, there will be empty space. So that place is empty, that's why it's called the hole. When the electron is goes from one place to another place, then that position there is no any kind of electron, so the empty side or empty place is called a hole. So when the electron is goes from the one place to another place, there is no any electron, so that place is called the hole. So this process, when the when this electron is goes from the here, this electron is goes to here. So when this electron is goes to here, here the hole is created. Even though this electron is goes from this side, then this place is become a hole. So hole is nothing but the place where there is no any kind of there is no electron. So this is the discrimination. This is the mainly difference. Some types is we said that the hole is contain that will be flow, but no, but its content is created by electron when the electron moves from one place to another place. So this is the most main differences. See that you can see that this is the doping process of n material and p type material, and whatever the impurities are sorry, whatever the impurities are doped, it is a trivalent impurities and pentavalent impurities: aluminium, gallium, boron, indium, and the pentavalent impurities just like the phosphorus, arsenic, bismuth, etc. So this is the basic idea about semiconductor devices. What are the semiconductor devices? Now we are start about uh, when you combine this p type and n type junction, it will become a p-n junction. It will become a p-n junction. Now later we talk about So we just stop the explanation till this topic. In the next time we will discuss about the PN junction and how it will helpful to manufacture a transistor. Thank you.